we were discussing the plastic hinge modeling of beams, RC beams, and we discussed how we can manually define a hinge and then assign it to an existing RC beam in our computer model in ETABS. So now let's continue the same discussion. One important point in that discussion was when we were filling that form for plastic hinge. If I go to define section properties and then wall frame wall nonlinear hinges, in that particular form we were using this particular option, use yield force, right? So actually we were asking the program to calculate the my or yield moment corresponding to the point B in positive and negative direction. We were asking it to be calculated automatically by the program, right? So program is using the cross section size which you have already defined, because when you define that hinge and assign it to a particular beam, that beam will have some cross section, and that cross section will have a material associated with that, right? So using that cross section and material properties, the program will calculate these scale factors, actually the yield moments in positive and negative direction. But one thing you should keep in mind, that program should be provided with the amount of steel, right, in order to be able to calculate that my. So if you have not provided the actual design reinforcement with all the cross sections of beams, then you cannot use this option, because that will be wrong in this particular form, right? So first you should go back and provide the actual reinforcement in define section properties, frame sections, and in that for all reinforced concrete beams, maybe this one concrete beam, you should provide the reinforcement by clicking on modify, and then it will give you this area where you can define the reinforcement. So apart from cross sectional properties, apart from a material associated with that cross section, you should also provide rebars here. So here it is asking you to provide rebars in both ends and in top and bottom of cross section, right? So and I top reinforcement, top area of steel, and J top area of steel, then similarly bottom I end and then J end, right? So we can provide the top and bottom steel here, and program will be using that steel to calculate your my, and also in auto hinge properties it will require that to calculate that rho minus rho prime over rho balance factor, right? So this thing you should keep in mind if you want to check that automatic calculation of scale factor or yield moment while defining the manual plastic hinge also, right? So if you run automatic design in ETABS, it can also use that reinforcement to define plastic hinge property, but that option is available in the auto hinge definition, right? So once we want to define our hinge ourselves, right, so we must provide the amount of steel first, right? This will be used to calculate my or scale factor for our moment rotation curve. So if you have, let's say, many types of beams or a beam with same cross section but many types of reinforcement, many different amounts of reinforcement, then you have to define a different cross section, right? So maybe the same cross section and same material may be having a different steel, so you have to define a new cross section and assign it to those particular beams in your model which have that steel. Ultimately in your computer model, all beams at all floor levels, they should have a realistic reinforcement which will be there as a part of final design, right? So you have to make sure that whenever cross section size is changed, you have a new cross section definition. Whenever a material is changed, you have a new cross section definition. And now another criteria, whenever the amount of steel is changed, but the other two are still same, you again have to define a new cross section, right? So you have to just provide the steel for all the beams in your model, and then you can go to define section properties, frame, wall, hinges, right? And then you can define a master hinge and then assign it to both ends of all particular beams, right? So once you define all the actual reinforcement behind all the cross sections of beams, you will come to know that how many hinge definitions you require actually, right? So if you have 20 types of beams having different amount of steel and cross section size and a material associated with them, then you should define 20 hinges and then select one by one all those hinges to which you want to assign a particular hinge which you have defined. So program will generate additional hinges and assign them those particular selected beams, right? So now we shift to auto hinge option, in which we do not first define a hinge and then assign. Instead of doing that, we directly select a beam and directly assign it the auto hinge using ASC 41 table. So program will do that whole process for us if we provide the basic inputs required to enter in that table. Program will directly pick the values from that table and define that hinge or populate that whole hinge form for us, right? So let me first quickly draw a particular RC beam, an example beam. Let's say that this is my concrete beam, and let me draw it somewhere here just for the purpose of demonstration. Let's say that this is my reinforced concrete beam, and there is a cross section associated with that beam, and that is this one. It is a concrete beam. So let me go back and see the properties of that cross section. It is a concrete beam, this one. Let me modify it. So it is a reinforced concrete beam having this material 4000 psi, which is a reinforced concrete material, and then these are dimensions, and then let me add rebar also. Let's say 3-inch scale at both ends, and same for top and bottom, right? So once I provide that, program will use that to calculate yield moment. So let me click OK, and now I have that concrete beam section, and that beam have that cross section. For auto hinge definition, I will simply select that beam and go to assign, and then frame, and then hinges, right? Same form will appear which we use to define a include a predefined hinge in our beam. But now instead of selecting that particular predefined hinge in that list, I'll simply click auto, select auto, relative distance is 0, and I click add, right? So that new form will open. That form actually is about the auto hinge definition. It is asking that from which reference you want to pick the modeling parameters and acceptance criteria. So I select from tables in ASC 41-17. There is a previous version of ASC 41 that is also available. Let me select 41-17, and then in that for beams, because in that particular cross section I have defined it as a beam M3 design, right? So program knows that it is a beam, so I can select a concrete beam or a steel beam. So this first option is table 10-7 concrete beam flexure item 1, which means flexure controlled. Similarly, there is an option for concrete column, steel beam, steel column, and others. So let me select table 10-7, and then the form is modified. Now it is asking me all those inputs which are required to enter in that table, right? Once we provide that, it will take small a, small b, small c from that table, and IOLS CP also, and automatically draw that moment rotation curve, define that hinge property and assign it to that beam which we have selected now, right? So degree of freedom should be M3. It is a beam, so primary moment is M3 moment. V value coming from, either you can select a particular case or combination, so but that combination should be run first, right? So program will directly pick the V value, maximum shear caused by that particular load combination, right? So you can define your design combination against which that beam is designed and select that combination, and then select this first option. No need to worry about that V, because program will automatically pick it from the available results of that combination, right, for this particular beam. Otherwise you can give a user defined value for the shear. So let me give my own value, let's say 160 kip. This is the transverse reinforcement. You have to check yourself whether it is conforming or not. So this is a checkbox which you have to check if it is conforming. If it is not conforming, uncheck it. Then finally this first parameter, rho minus rho prime over rho balance. So first option is from current design, which means whatever reinforcement currently the program have. That can be from two sources. One is that you run the design first and the program will automatically use that reinforcement to calculate this factor. Other is that you provide the reinforcement first in the cross section, which I just did in the start, and program will use that one. So currently no analysis is run in this model, no design is run in this model. So when I go for this first option, program is going to use that 3-inch square which I provided in the cross section of that particular beam, right? So whenever we assign this auto hinge to any beam, whatever reinforcement you have in that cross section size, it will use that and pick the small a, small b, small c, IULS and CP values and plot that you can say moment rotation curve. Second option is user value. Again you can give your own value for this whole factor, rho minus rho prime over rho balance. In that case you have to manually calculate it for this particular beam which is selected and then give the value here, right? So let me just go for first option. Last is the deformation controlled hinge load carrying capacity. Drop load after point E, or it should be extrapolated after point E. This option was also available when we were manually defining the hinge. So we have to select one of these two options and then I'll click OK, right? So now the hinge is defined for one end of that beam. Let me simply type 1 here and click on add again. The same form will appear. I'll provide the properties for the other end and I'll click OK. And now both auto hinges M3 are defined at both ends. I will click OK and now you can see it is showing me B1H3 and B1H4. These two are the two auto generated hinges. And now I can go back to define section properties, frame wall, nonlinear hinges, and now you can see that when I click on show generated properties, these two auto generated hinges are already there in your list. So you didn't define a master hinge and then assign it to a beam. You directly select a beam and define an auto hinge, right? So now you can modify that and then modify again. So you can see that program have already developed that moment rotation curve for you and already calculated the my, which is locked here, already picked the IULS and CP in the form of plastic rotations, right? So already picked them from ASC 7 table and fill this whole thing, right? So this option can also be used if you want to save time. Instead of defining your own hinge first and then giving it to your beam, assigning it to your beam, you can auto define hinge directly. So this will save also time, because if there is any interpolation required between different rows of that table 10-7, program will do it for you already, right? So one thing which is a drawback for this auto hinge option is that you don't have much control on the properties, although you can since they are locked already. So what you can do, if you want to modify, you can convert them to user defined. So here you have convert auto hinge to a user defined property, right? If you convert it to a user defined hinge, then you will have a control to modify it, right? And you should always do it for reinforced concrete elements, because here if I go back in that property, you see all other things program have automatically calculated, and one of the thing is this hysteresis type also, right? So hysteresis type is by default selected as isotropic, which can be appropriate for metals but may not be appropriate for concrete, right? So this is one drawback which you have to modify, and it will take your time if you want to do it. Let's say I convert it to user defined, so now its property is no more auto. Now if I modify it, now I can change everything in this particular hinge property, right? So now I can change all those values, IOLS, CP, and also I can select a different hysteretic model which is more suitable for my reinforced concrete moment rotation curve, right? So I can give it concrete or degrading, which is more suitable for my RC case. But now in the latest version of ETABS, I think they have already put this option while defining auto hinge, right? So now even that effort will not be required to convert it into manual and then change it hysteresis behavior manually. In the latest versions, you have that hysteresis option directly in the same form where you define ASC 41 parameters, right? So in the same form they give you this option. So if you want to provide a particular hysteretic behavior, you can define it there, and then your auto hinge will be having that hysteretic behavior. So this is a kind of a shortcut to that complete process of first defining, and then you can always modify it, because if you want to add new points, or you can change the auto calculated my value or scale factor, you can change that afterwards by converting it into user defined hinge. So once you define all those plastic hinges for all beams, now you can say that your beams have the capability to yield or show damage after the analysis, that can be nonlinear static analysis or nonlinear dynamic analysis. So let's say that I defined hinges for all beams. Now I can perform nonlinear dynamic analysis if, for example, I don't want to model columns as nonlinears or shear wall as nonlinear, right? But otherwise obviously you will convert your columns also to nonlinear, and then shear walls also. But for that we will be discussing fiber modeling approach.